Hello, welcome to my channel. Today we will discuss on the tutorial questions on chapter 4 forces. Okay, so the first questions, a load of 250 kg is hung by a crane cable. The load is pulled by a horizontal force such that the cable makes a 30-degree angle to the vertical plane. If the load is in equilibrium meaning that it's static, okay, meaning that is equilibrium means that is balance. So they ask us to calculate the magnitude of the tensions for the cable and also the horizontal force. Okay, so let us start to answer the questions. Okay, so before we answer, you must draw free body diagram first. Okay, so usually when you want to draw free body diagram, okay, you need to ask 5 questions. Whether, okay, because we have 5 forces. Let us recall back what are the 5 forces that involved in this chapter. Okay, so the first one is the weight. Then we have also the normal force or the reaction force. We have the frictional force that is related to the friction between the contact surface. We also have tension, and also we have F external force, okay, which is push and pulling force. Okay, so the first one, if you refer back to this crane, the object here, we have mg, we have F external, and this object is pulled by the horizontal force and makes the angle of 30 degrees to the vertical. Okay, meaning that the angle here is 30 degrees and this is the tension because there is a string. Okay, so if we draw out the free body diagram, meaning that total we have 3 forces. The first one is F external, and then we also have the weight and also tension. Okay, where tension, this is 30 degrees, or if it's near to the x-axis, it will be 60 degrees. Okay, so this is the first step. Remember, always draw free body diagram. Okay, the second step is you need to resolve it into x component and also y component. Okay, so the first equation, the resultant force for x component equals to ma. Okay, because the question say the load is in the equilibrium position, okay, meaning that it's static, it's not moving, so our A is equals to 0. So we write here 0. Okay, and then here for x component, we have 2 components. One is a F external, the other one is a tension. So we write F external because it's to the right, so we write F external minus tension cos 60. Okay, you need to resolve it into tension x component is to the left, so this is your Tx, and going upward, so this is your Dy. Okay, so Tx will be negative T cos 60. Okay, so F external is equals to tension cos 60. Okay, because it's equilibrium, meaning that the force acting on the left hand side must equals to the force acting on your right hand side. So we can calculate. Okay, we can calculate later. So this is our first equation. Okay, next, Fy equals to ma. And because the question says it's static, so again our acceleration is equals to 0. Okay, so we the equations that we get is Ty is T sine 60, okay, which is acting upward, minus weight equals to 0. Okay, or we can write it as T sine 60 equals to weight. Weight is equals to mg. So this is the second equations that we can get. Okay, after that you can do it simultaneously, where we know that the m here is given 250. Okay, so we can write as T equals to mg 250, g is 9.81. Okay, you don't need to substitute negative here. Okay, we only take the magnitude 9.81. Okay, because we already consider the direction negative. Negative showing downward just now, so we don't need to substitute negative into 9.81. Okay, then over sine 60. So the tensions that we get, okay, on the string, on the cable, is 2,832 Newton. Okay, so it's 2832. The answer here is wrong, so please do correction. Is 2,832 Newton. Okay, after that we substitute into the first equations to find the F external. So F external is equals to tension 2,832 cos 60. Okay, so if you press calculator, you will get 1,416 Newton. Okay, so this one also changed the answers wrong, is 1,416. So this is our first questions. Okay, next we go to questions number 2. Questions number 2, calculate the magnitude and directions of the force that balance the three forces. So again, the word balance here. Okay, balance means that equilibrium. Okay, seimbang, meaning that the force acting on left hand side and right hand side should be the same. Force acting upward and downward should be the same, because the question said it's balanced. Okay, so we want to calculate the magnitude and directions of a force that balance three forces acted at the point A as shown. Okay, so meaning that these three forces actually is not balanced, so we need to add another extra forces. Kita perlu tambah extra force supaya dia seimbang in order to balance the three forces. Okay, but we don't know where should we put, so we just assumes that it is F. Okay, so here we need to resolve it into, okay, here we already have 1, 2, 3, 4. Okay, so we need to find the F extra to balance these three forces. Okay, so we write in F net first. For x component is equals to MA. Because the question said balance, so meaning that A is equals to 0. Okay, so for Fx, okay, Fx, F1 is going to the right and going upward. Okay, your F2 is to the left and going upward. F3 is to the left and F3y is going downward. Okay, so we need to resolve it one by one. Okay, so we go for x component first. So for x component, we have F1. Okay, for x component. Okay, minus F2 for x component, minus F3 for x component, and we plus F4 for x component, where this value we don't know what is the value yet. Okay, we need to find out first. So its total is equals to 0. Okay, so we substitute all the value inside. 12 cos 55 minus 20 cos 30 minus, because to the left, 30 cos 45 plus Fx 4 equals to 0. Okay, so you will find out that your F4 for x component, okay, is equals to 31.6 Newton. Okay, so this is for x component. Okay, we need to find x component and y component later. We find the magnitude and also the direction. So next step is Fy equals to MA. Again, because the words balance, meaning that equilibrium, seimbang, so this is equals to 0. It's static, it's not moving. Okay, so again, F1 for y component upward plus F2 because it's upward, so it's positive, F2 y component, minus because F3 is downward, minus F3 for y component, plus F4 y component, where we don't know what is the value. Okay, and is equals to 0. Okay, so then we substitute all the value. 12 sine 55 plus 20 sine 30 minus 30 sine 45, minus because it is adding downward. Okay, minus because it is adding downward. Plus F4 for y component and is equals to 0. So if you press calculator, you'll find that F4 for y component, the answer is 1.37 Newton. Okay, 1.37 Newton. Okay, so now you already have x and also y component. Okay, next is we need to you need to find the magnitude. Okay, so step number 3. Okay, just now is step 1, you find x component. Step 2, you find y component. Step 3, you need to find the magnitude. Okay, so always remember we have 5 steps to find the value. So the magnitude we use is F4. The resultant, the total is F4 for x component square plus F4 for y component square. Then you substitute in the value 31.6 square plus 1.37 square third. So you will get 31.6 Newton. Okay, step 4 is the direction. Okay, so direction, still remember what is the equations we use? Yes, we use tangent theta to find the direction. We use y component over x component, and usually we modulus because we only want the basic angle. Okay, so Fy is 1.37, Fx is 31.6, we modulus. Okay, so after you add tangent, the angle that you get is 2.48 degree. Okay, and we go to step 5. Okay, step 5 is you need to sketch the graph. Okay, so how can we sketch the graphs? We must refer back to x and also y component, where our x component is positive, y component, the resultant, also you get positive, meaning that it is positive to the right and upward. Okay, so we know that it is at the first quadrant. Okay, so this is step 5. Okay, where you need to sketch. And finally, if you want to write the conclusion, you can write the conclusion where the force, the extra force F4, okay, the magnitude is 31.6 Newton. Okay, at the angle of just now we calculate is 2.48 degree above, because it's at the first quadrant, positive x exit. Okay, so this is the conclusions that we can make after 5 steps. Next, we go to questions number 3. Okay, you may pause the video if let's say I'm teaching too fast. Okay, next, questions number 3. Questions number 3, a window washer push, okay, his brush up a vertical window at constant speed by applying a force. Okay, so this force actually we are referring is because it's push. Okay, so actually this is a F external force. Okay, this is the F external because the word is push. Okay, and the brush width is 10 Newton. Okay, so already give you the weight, and the coefficients of the friction is 0.125. Okay, so remember we always start with draw the free body diagram. Okay, so we must ask 5 questions. Do we have weight, normal force, frictional force, tension, and also F external? So the first one, mg. Okay, for the brush, yes, we have mg. Weight, normal, yes, because the brush is contact with the wall, so the normal force is perpendicular 90 degree with the contact surface, so your normal force is to the left. Friction, yes, because the questions already give us the kinetic friction, so there's a friction. Okay, so friction, the directions of the friction is always opposed to motion. So from here, because the question say it is pushed upward, so this is the motion, push upward. Okay, so motion. So our friction is opposed, so meaning that our friction should acting downward. Okay, because the motion here is push upward. Okay, so the frictional force should acting downward, opposed the motion. And we have tension or not? Yes, we don't have tension because there's no string, no wire, no cable. And F external, yes, already given. So we draw out all the forces involved. Okay, here is the F external. Okay, F external, and the angle given is 50 degrees. We have weight, and also we have frictional force, and also another force is the normal force. So there are 4 forces involved. Okay, after sketch or draw the free body diagram, the easiest one is you need to resolve it into x component and also y component. So we go x component first. The resultant Fx equals to ma. So we want to know whether a is equals to 0 or not. Okay, so from the questions just now, the question already mentioned just now is constant speed. Okay, constant speed meaning that is a equals to 0. Okay, because the question say constant speed. Okay, so our a is equals to 0. It's moving but with constant speed. Okay, so x component here we have normal force and also F external, where our x external we can resolve it into to the right and acting upward. Okay, so our equation for x component is our F external, where our F external is not given the value. So if x external cos 50, because it's equilibrium, so it will equal to normal force. Okay, so this is our first equation. The second equation is from your y component. Okay, and again, because the question is moving in constant speed, so it's equals to 0, meaning that the force acting upward must equal to the force acting downward. So the force acting upward is our F external, where F external sine 50 will equal to, or you can minus friction minus weight, okay, equals to 0. Okay, so when we write again, we find out that actually the equation is the force acting upward is equals to the force acting downward, the friction and the weight. Okay, so this is our second equations. So after obtain all these equations, we can solve it. We can find the questions by using the simultaneous. Okay, so what should we do is the first step, we need to find we can substitute here. Okay, F sine 50 equals to F. The equation for F, we have another equation, F equals to mu n. Okay, so we can change it, become mu n. Okay, plus the weight, where they give you the weight is 10 Newton. Okay, then F sine 50 mu 0.125. Okay, normal force we don't have, but we can take it from the first equation. So we substitute inside F cos 50 plus 10. Okay, after that we try to simplify it, where F sine 50 minus 0.125 F cos 50 minus 10 equals to 0. Okay, so we try to factorize out the force. Okay, so the F external here is F external. Okay, so you find out that the F external is equals to 14.6 Newton. Okay, after you get your F external, you substitute back to find the normal force. Okay, so our normal force will equal to 14.6 cos 50 and you will get the final answer for the normal force is 9.39. Okay, so this is for questions number 3. Next, we go to questions number 4. Questions number 4, the system in the figure is in equilibrium. So again, the questions towards that is equilibrium, meaning that is balance, okay, with the string at the center exactly horizontal. Okay, so calculate the tension 1, tension 2, tension 3, and the angle. Here we have 2 objects. Okay, so when you want to draw free body diagram, you need to split it. Okay, you need to split it one by one. Okay, so we look at the first load first, 40 Newton. Okay, we draw the free body diagram for the first load. So for 40 Newton, okay, we have normal force, we have tension. Let's say I label it as T. Let's say I label it as T4. Okay, of course, at this point, we have tension 2, and also we have tension 1. Okay, if we are referring to this point, there also tension 4. Okay, so if we are referring to this load, the 40 Newton's load, the 40 Newton's load, we have the weight. Of course, the weight is equal to tension 4. So we know that tension 4 is actually the weight. Okay, so we draw the first free body diagram for this point first, where at this point we have tension 2, we have tension 1, where the angle here is 35, so here will be 55, and we have tension 4, okay, where tension 4 actually is the weight. Okay, so this is the free body diagram for the first point. Okay, the second point is this one. Okay, so if we are referring to this 50 Newton, this 50 Newton is actually equals to, let's say, T5. Okay, so our T5 is actually 50 Newton if we are referring to this load. But if let's say we are referring to this point we have tension T3, we have tension T2, because they are same string, so T2 for this point and the other point are the same. Okay, and we have another cable, so this is our T5. So we found that actually this, because this is the same string, so T5 and T5 here, actually we know that T5 is equals to 50 Newton. Okay, is equals to the weight. So we draw the second free body diagram where we have tension 3 and the angle we don't know. Okay, this is the theta and this is T2. Okay, and also we have T5 where our T5 actually equals to 50 Newton. Okay, so we have 2 free body diagram because we have 2 objects. So first one, you need to resolve it one by one. Okay, let's say object 1 first for 40 Newton. Okay, so our Fx equals to, because it's equilibrium, so it's equals to 0. Okay, force acting to the left must equals to force acting to the right because it's equilibrium. Okay, so if you're referring to the first load, this point we have T1 cos 55 is acting to the left is equals to T2. Okay, for y component, so this is our first equation. For y component is also equals to 0 because it's equilibrium, static. So the force acting upward must equals to the force acting downward. Okay, so for this one, upward is T1 sine 55. Of course, you want to take cos 35 also can. You get the same answer. Equals to the weight, and the weight is, for the first one, is equals to 40 Newton. Okay, so we have T1 equals to 40 over sine 55. So the first value for T1, okay, the value that you will get is equals to 48.83 Newton. Okay, then you substitute into the first equation. Okay, you substitute into the first equation where T1 cos 55 is equals to T2. So our T2 is equals to 48.83 cos 55. So you will get T2, the answer is equals to 28 Newton. Okay, so this is X and Y component for the first object. Okay, next we go to the second object where we have also three forces. Okay, so we resolve it one by one. X component equals to MA, and again because it's equilibrium, so A equals to 0. Okay, the force acting on the left equals to force acting on your right. So on your left, T2, on your right is this one. Okay, so this is T3. T3 for X component is X, T3 sine theta. Okay, because the theta is near to the Y axis. Okay, so we write it as sine. So T3 is equals to T2, 28 over sine theta. Okay, where theta we don't know what is the value. So this is our equations number 2. Okay, we need to find out. Okay, next is you need to find for Y component. Okay, so for Y component, Fy equals to MA, and MA, A is 0. So we write 0. So again, because it's equilibrium, meaning that the force acting upward must equals to downward. Okay, so upward is our T, this one, T3. Okay, so I write as T3 cos theta equals to 50. So our T3 is equals to 50 over cos theta. Again, we also don't know what is the angle theta here. Okay, but here we know this is T3, here also T3. So we substitute equations 3 into equations 2. Okay, where we know that 50 over cos theta is equals to 28 over sine theta. Okay, then we use sine theta over cos theta. Okay, is equals to 28 over 50. So sine theta over cos theta, actually you will get tangent theta. Okay, is equals to 28 over 50. Okay, 28 over 50. So you add tangent, the angle that you get is 29.25 degree. Okay, so we already find the angle theta. Okay, but we still don't have T3. So we need to use the angle theta to find T3. So now, okay, we go to equations number 2 just now. Okay, where T3 is equals to 28 over sine. So you just substitute the angle 29.25 into. Okay, so after you press calculator, you will find out that the T3 is 57.31 Newton. Okay, so this is questions number 4. Okay, next we go to questions number 5. Questions number 5. So this is questions number 5. A 20 kg ball is supported by a shielding by the rod, okay, of A, and a rod of B pulls downward. Okay, the B is pulled downward and to the side on the ball. If the angle of the vertical is 20 degree and if B makes an angle of 50 degree to the vertical, determine the tension in the ropes of A and also B. So this ball is tied with 2 rods where A and B. So we need to draw a free body diagram first. Okay, we need to draw free body diagram. So every time when you want to do this type of questions, you must draw free body diagram. Okay, so the first one, we have weight. Okay, weight is acting downward. We have tension. Okay, this is tension B, and this is your tension A. We don't have friction because there is no contact surface. We don't have normal force. We don't have external force. Okay, so we draw out all the forces. Okay, we draw all the forces into a free body diagram. Here we have the normal, the weight, and also we have tension B. Okay, the angle here is 50, where the angle here will be 40. Okay, angle is equals to 40. Okay, and then your tension A and the angle here is 20, meaning that this will be 70. Okay, so it's up to you whether you want to use 20 or 70. Okay, so this is our free body diagram. So next is we need to resolve it into x and also y component. Okay, so for x component, fx equals to ma. Okay, fx equals to ma. And a, the question say it's not moving. Okay, it's in equilibrium. So therefore, we know that our a is equals to 0. So again, because it's equilibrium, meaning that the force acting left must equals to the force acting to the right. Okay, so to the left here we have tension A, where tension A, x component is tension A cos 70 equals to the right, where is tension B cos 40. Okay, so this is our first equations where we don't have tension A and tension B. Okay, we go to next equation. The resultant force for y component equals to ma, and again is equals to 0. So meaning that the force acting upward must equals to the force acting downward. Okay, so upward we have tension A sine 70. Downward we have tension B sine 40, and also we have the weight, where the weight here the questions give us the mass m. Okay, this is mass in kg, not the weight. Okay, so you must time 20 times 9.81. Okay, so you calculate your TA, then later you substitute inside. Okay, so your TA will equals to, okay, TA is TB sine 40 plus 20 times 9.81 over sine 70. Okay, so this is our second equation. So we substitute equation 2 into equation 1. Okay, where our TB substitute sine 40 plus 20 times 9.81 over sine 70. So this is TA, and then here we have cos 70. Okay, because here we have cos 70. Okay, is equals to TB cos 40. Okay, so you rearrange back the equations. Okay, so you will get TB. Finally, you will get TB is equals to 300. Okay, so you will get your TB is equals, is equals to 133.9 Newton. Okay, or we can round off become 134 Newton. Okay, you can round off become 134 Newton. Then we substitute back into TA. We substitute back into our TA, where our TA you will get, after press calculator, you will get 300 Newton. Okay, so remember the correct answer must have the correct unit as well. Okay, so that's all for today. Questions number 6 and so on. Okay, please watch my next video. Thank you, class. See you. Bye.